Hi guys, my name is Ernest and this is Ernest Sciences and Mathematics TV channel. I'd like to welcome all the members into our discussion for today and kindly request that we subscribe and engage ourselves in the comment section and also ring that notification bell to be getting updates on our various uploads. Now in our discussion today, I'm going to look at force on an electric charge moving in a magnetic field, and this is going to be cementing on our previous discussion whereby we have had on the concept of interaction between the current and magnetic field, the current and of course electric fields, and of course other aspects of electricity and magnetism. Now in this case, we're going to look at how we can evaluate this aspect of a force, which is going to be experienced of course on an electric charge which is interacting with a magnetic field. Now I'm going to use this this specific illustration which I've given on the right side of my board, whereby I have these two specific wires which are going to be, of course, carrying currents. Now, perhaps I'm going to give them in terms of this specific, of course, I can just have this specific labeling. So we're going to have this one as wire 1, which I can give in terms of 1, and then we're going to have wire 2 given in terms of 2 given as such. So in this case, this wire is going to carry a current given as I1, and then this is going to be I2 given as such. So this is going to be the distance of separation between these two wires which are carrying currents. I is going to be my, of course, current which is flowing between those wires for 1 and 2 respectively. And L is going to imply the length of this specific wires which I'm going to use for my particular illustration. Now in this case, if the two wires are going to be separated by a distance of d, as I have said, each is going to produce a magnetic field from the previous discussion we had, which is going to be felt by the other due to their presence within this specific proximity of D, and therefore each is going to exert a force on the other one. Now for us, we're going to evaluate on this specific force which we are going to, of course, be experiencing for the two wires due to the presence of each other, and of course the magnitude of the magnetic field which is going to be produced by each of those specific, of course, conductors. Now, in this case, I can just give this one in terms of as well labeling for this. So the Y1 is going to produce a magnetic field which is going to be given in terms of B1, while this one is going to be producing a magnetic field given in terms of B2 as such. So we can additionally say that this L1 is going to produce a force given in terms of F1 and F2 given as such. So we have touched on various aspects of this interaction between different, of course, types of perhaps forces and of course, the presence of or the interaction between these two specific conductors. And therefore, we are going to give this one as a magnetic field being given as B. And of course, F is going to represent what we refer to as a force being experienced. Now, in this particular case, we're going to find a relationship or a way in which we can represent this specific force. Now, we had mentioned that we can find the magnetic field produced by either of these specific wires. Perhaps we can start from that one in order for us to start this specific evaluation. So we can find the magnetic field produced by these specific wires. For instance, for B1, we can find this magnetic field as a product between mu naught, and I mentioned that basically this aspect of mu naught is going to be the permittivity of free space, which is of course going to be a particular constant. Now I'm going to give this a specific figure for the sake of reference. Now in this case, this is going to be equivalent to between mu naught, and then we're going to have the current divided by the product over 2 pi d given as such, where d is the distance of separation being given as such. So if you try to look at this, this basically is going to be the magnetic field that is going to be produced by this specific line 1. And as I had mentioned, this aspect of mu naught is equivalent to 4 pi times 10 negative 7, of course, which is going to be given as a Tesla meters per, of course, amperes given as such. So in this case, this is going to be the value of this particular permittivity of free space. And from this specific case, of course, we can as well indicate the force which is F2. Now, F2 is going to be the force being experienced by this specific wire due to the presence of this one. And therefore, we are going to be finding or evaluating for F2 exerted by B1. So this is going to be F2 exerted by B1, magnetic field of B1 as we have said. And therefore this can be given in terms of its length over L2 of the wire, which is going to be carrying the the current over L2. And this is going to be given as the product of, so the force F2 is a product of the current, which is I2. And then we're going to have due to, so the force on I2 is equivalent to the product of I2 due to the presence of a magnetic field of the intensity of this specific magnetic field of B1, and then we shall have L2 given as such, its specific length. So this is going to imply, so let's have this one as our equation 1. So this is going to be our equation 2, which is going to imply the force being exerted on L2 due to the presence of this magnetic field of B1 given as such. And of course, we're going to see that in this particular equation, we have had this particular notation for the B1, and therefore we can do a substitution for this one over F2, which is going to give us I2. And then for B2, we are going to have mu naught I1 for this one, and then L2 divided by 2 pi d given as such. And this is going to give us F1. Perhaps we can do a rearrangement for this one and have F2 given in terms of this mu naught. And then we're going to have I1, I2, L2 divided by 2 pi d given as such. So this is going to give us the magnitude of the force which is going to be experienced for F2 on an electric charge that is going to be moving in this specific magnetic field. And of course, we're going to see that similarly from this one, we can have an analogous equation for the force extended by B2 on L1. And of course, that's going to be given by, of course, a formula which I can give in terms of F1 is equivalent to mu naught, which is a permittivity over free space. Perhaps I give it in terms of the permittivity of free space times the current 1, and then we're going to have the current 2 L1 divided by 2 pi d. So this is an analogous equation which is going to be written in this specific format, and we're going to have the two equations which are going to represent the particular forces which are going to be felt by F1 and F2 given as such. So perhaps we can evaluate one or two examples which are going to form a final bit of this specific discussion on the concept of a force on an electric charge moving in a magnetic field. And in this case, we can have this one in terms of an problem set, whereby I'm going to read this question, we extract the information, and then we are going to use it in doing our specific evaluation. So two wires of length 0.2 meters. So we're going to have L 0.2 meters. So these are two wires for L1 and L2 equivalent to 0.2 meters long. Appliance cord are 4 meters apart. So the distance 4 millimeters apart. So this is going to be 4.0 millimeters apart for D. And then they are going to carry the current over, so I is equivalent to 2.4 amperes. They are going to carry the current of 2.4 amperes DC. And then we are required to find the force on the force one wire exerts on the other. So this force is generally going to be represented in terms of F, which is equivalent to mu naught, and then we're going to have current on wire 1, current on wire 2, and then the length of this specific wire, and then divided by 2 pi d given as such. So in this case, we are going to do a direct substitution. And I'd say that this mu basically is permittivity of free space equivalent to this specific figure. And then we shall have the current given as 2.4, and then to each was carrying this specific amount of current. And then we shall have the length given in terms of 0.2 meters pi times the distance between them, that is 4.0 times 10 negative 3 meters. So I've converted this one from millimeters to meters given in that specific of order, and that's going to be giving us the force which is experienced by each of these specific wires. Now from my end, I'm finding 5.76 times 10 raised to negative 5 newtons as the force which is going to be experienced by each of these wires. Kindly, if we find a different figure, then you can notify me on the comment section. So that is it for now, guys. Bye, God bless you. Catch us in our next video.